Forget. OBS says it's recording. Hope it's right. If not, sorry. Major McCheese, huh? We got a couple minutes still running to get started. So I apologize. I have a stutter. So if I stutter here and there, just please forgive me. Oh no, someone's stuck building YAML pipelines for work. That's horrible. I mean, it's great. Like, but it's always a non-trivial task. For me, anyway. We have a challenge at work where we argue about should we do everything with bespoke PowerShell or use custom tasks. Because we want to be able to, we desire to run locally, right? And have the same experience in the build pipeline. Yeah, that's what we do, Patrick. We're working towards that. We use Pisaki and something else. I can't remember. I hope OBS will let me cut off the beginning of this to when we actually start. All right, we hit 3 o'clock. Yay! So I'm going to go ahead and get started. I have a repo out there. It's pretty empty right now. It's just a QR code, so feel free to scan it. I also dropped a link to it in the chat for this event. I don't know how many of you people have heard of this, but .NET Orleans is a distributed computing platform that has become native. Native is probably the wrong term, but native to .NET 7. Prior to that, we had .NET Orleans version 2, version 3. Version 3 was probably the fairly popular, and it's an actor-based distributed computing platform. Actor frameworks are great, but they have a lot of overhead for devs. Right? So if you've ever used Akka.net, which is a port of Akka, or other actor frameworks like that, Service Fabric uses actors, and they can be challenging to maintain, and they can be challenging to debug, and it puts some constraints on devs. So what Orleans aims to solve is, let's make this simple, right? So we're going to give developers a simple programming model, and we're going to put a bunch of the work required to make these things work as expected under the covers. Actors are in an actor model, actors are the unit of computing, right? So they take messages in, they do work, they return data. In some cases, they store state. So Orleans allows all these things, right? So the Orleans uses something called a virtual actor model, which they pilot. There's other virtual actor frameworks out there now, like Dapper, not to be confused with the SQL Access, but Dapper, DAPR, which is, I don't remember what it stands for, but it is a competing framework to Orleans. Orleans actors are called grains, right? So grains fit in a silo, and according to Microsoft, a single silo can hold enough grains for every person on the planet without issue. They all can't be active at the same time. So grains have a life cycle, right? They start they are active in memory. So when a grain is born, right? I would, and I'll demonstrate this in a few minutes. But when a grain is born, we'll just ask for it. We'll say, hey, give me the grain for the account called Mayor McCheese, right? And suddenly we have a grain. And it may have state and it may have things like that. It may not exist yet, but we can just treat it as if it's there, right? So that's the beauty of some of the actor model that's in there. And then we have a life cycle where it'll deactivate and persist to our storage if we have storage. It's not a required function. And then we can reactivate that grain when we need it. So if you have a grain for every single person on the planet and they're all active at once, you're in for a bad day. So there's definite places where Orleans fits. If you have a high volume transaction system where transactions are coming in all the time, it might be overwhelming. You might have to manage multiple silos. So in the past, I've used Orleans at 2 different companies. The first foray I had into Orleans was in a manufacturing company, and we used Orleans to help manage our inventory system. So we had a highly complicated inventory system where we had systems of record ranging from an AS400 to a product information management system, so a PIM system, and a number of other systems within the manufacturing concern. So we used the SKUs for different items that we sold as our actor partition, right? So when we needed a SKU, we would check the grain, and then in the back end, the grain would manage the 15 to 20 second refresh cycle. So instead of having an API that gets called, and I'm sure you've seen this before, it's not fun, right? People end up in this microservice land where they have an API call to their inventory, and suddenly your microservices are calling each other. So the inventory system calls out to the AS400 endpoint that's been exposed, and then we're calling into our ERP endpoint, and then we're calling into some Cosmos database where we store information from PIM, and we have a variety of sources, and all these things get slowly rectified to build out data, right? So we used Orleans to build in the idea of an actor where the state was our inventory, and then on a reminder cycle, it would go out and say, oh well, let me refresh this stale data. So users weren't victims anymore, right? They weren't victims of what goes in cache. Like the actors bore the brunt of that. And then a couple of years ago, I worked for a rideshare company. It was a startup, and we used Orleans to manage our whole ride flow system as well as a reward system, so that when riders would ride, they would earn points for a ride for doing things like reviews, providing email address information like that. And we had to support, in practice, 18,000 transactions per second in our reward system. I'm sorry, in theory. In practice, we didn't get that high, at least not when I was there, but we built that reward system using Orleans, and it was very efficient. So, with that intro, like, I do want to get started with some code, right? So I have an empty repo right here, just our happy little concept. So let's go ahead and create some code. I'm going to go into our source directory. And I'm going to keep an eye on the chat, so if anyone has questions, just feel free to shoot them out. So we'll make a new server. We don't need a solution, right? So we'll say console. We'll call this guy ping server. Ooh. And so I want to go into our ping server. And what do we need to get started with Orleans? It's really pretty easy. Let me do one thing here. Oops. I'm going to add this to our solution. We'll go ahead and reload that. Are you guys not seeing my screen? Oh, I'm not sharing the right screen. Oh, well, let's do this then. Is that a little bit better? Let's close our preview. We're not going to really need that right now. And I'll make sure we zoom in on this side as well. I am recording this as well, and I apologize. I have a large screen. So creating a server in Orleans is pretty simple. We actually just need one package. So I'm going to .NET add package. We're going to need dependency injection. I'm going to add that. I'm going to add hosting. And what we need for Orleans is just Orleans.server. Prior to this, and this is important to note that if you look for documentation on Orleans, a lot of the documentation you'll find is for Orleans 3.5. It's a little more complex to get going with 3.5. Everything I'm doing is available in .NET 7 today. And I'm going to zoom this up to 200%. I don't need any of this stuff, so I'm going to add a host. And we'll just say host builder. Oops, host. It's going to create a default builder. I will calm down as this goes, but I'm like shaking so hard doing this because my anxiety. I apologize. So I can use Orleans, and we can pass a silo builder in. So I'm just going to say silo, do a little lambda, leave that alone for now. We'll configure services. Not terribly worried about this right now. Our services portion, and then we'll just build. So for our silo, for now, everything we're going to deal with is just the local cluster. So silo.use local clustering. And we now have, this is important because I always forget to do this. I want to say host.start async. And at this point, we would have a running cluster. It wouldn't really do anything, right? But that's okay. So when what we need to add is the grains, right? So when we have grains, when we want to deal with a client and a server, we want the client to be able to understand what our data contracts are as well as the server. So in an effort to do that, my fingers are offset on the keyboard. I'm going to say .NET new class lib. We'll say evening or well, we went with pain. Sorry. I usually go with a contracts library. And pain.contracts. Yep. I want to save our program. If I look at my Solution Explorer, I have this class 1, we'll just reuse that. I want a new interface. And I'm going to call this iPing brain. It's a convention. It's not a required convention. If you don't name your interface XYZ grain, that's not a problem. But you do need to inherit from, sorry, I need to add a NuGet package to this. And I'm going to add Microsoft Orleans SDK. We'll install that, and that'll give us access to the base grain programming model. So we have a variety of grains that we can support. So we have iGrain with GUID key, integer key, string key, some compound keys. I'm going to stick with string key for the moment. And this is a scenario where I meant to say this earlier. If this is popular enough and people are interested, I'll do a follow-on with this, and we'll do some more advanced scenarios. But for now, I'm gonna try and get through basic Orleans, and then we'll do some more advanced scenarios with grains, persisting, and journaled grains. Journaled grains are pretty interesting, and they solve some unique problems. And then reminders and timers if we have time. And that'll be a lot to get through. Orleans is as complicated as you want it to be. So it can be super duper complex with providing everything from, if you have multiple silos, like where do grains go and how do we decide what silo goes in any grain. A note on grains and silos, there's only ever one grain for an actor at a time. So if I have an account that's the Mayor McCheese account grain, that grain will only exist in one silo at one time. So I don't have to worry about, like, from a state perspective, am I not consistent? Am I not available? Like, what's my partition tolerance? I don't have to worry about those things. Orleans takes care of it for me. And that can be good and bad in certain scenarios. If I have a large number of silos that are globally distributed, I could be in a bad location and could experience some slowness and that sort of concept. But I've never been in a globally distributed scenario, so that is not something I'm very familiar with. But we'll go ahead and add a task, and we'll just call it ping. So we have a simple task. So we'll go ahead and add a reference to our server. Project reference, ping contracts, say OK. I'm going to add a lot of the documentation for Orleans will tell you to do this, and I'm going to do it. But I'm going to say that typically you don't have to. I'm going to call this ping grains. And we'll use .NET 7. So ping grains is going to hold our grains. So I'm going to go ahead and let me fix this before I forget. I am using ReSharper. I grew up on ReSharper, so forgive me. So we're going to add our same SDK. I don't want to go through the NuGet screen, so I'm just going to copy our package reference and grab that whole item group and throw that into here. Instead of going through all that. So I'm going to create a grain. Creating a grain is very easy. So we want to create a ping grain. We need to inherit from grain. And we need to inherit from our, sorry, I need to add a reference to contracts. And we'll add our ping grain. And we'll go ahead and implement that for now. Just gonna do something simple. I'm going to say I logger ping grain logger. We'll introduce that as a read-only field. And here we'll say logger dot information. We'll say ping at and it's a task, so we'll just return task.completed task. And we'll go ahead and add that grain here. We'll add a project reference to our grains. Now, one of the nice things about Orleans, I don't need to tell Orleans about what my grains are. I don't need to say, oh, here's this ping grain that we just created. Orleans will figure that out for me. So there is some reflection that goes on in the background, but Orleans is pretty well optimized. So we shouldn't be super afraid of the reflection that happens on the covers. So I'm going to go ahead and add one more project. And I'm going to actually, yeah, we'll just add it this way. Add new project, and we'll create another console application. And we'll call this guy sender. .NET 7, create. This is going to be a slightly different, right? Because this is our client. So our client, we're going to go ahead and add another NuGet package. That's an Orleans NuGet package. Manage NuGet packages. And we'll look for Microsoft Orleans client. And we'll go ahead and install that guy. For purposes of our demo, we'll go ahead and I actually want to grab our hosting and dependency injection as well. So we want our host builder, create default builder. We're going to use Orleans client. And it's going to say we're going to pass in our client builder. And for this, I'm going to say client use localhost clustering again. Now, localhost clustering, if we hover over this, is going to tell us essentially that it's going to use some sensible defaults. We have a service ID of dev, a cluster ID of dev, a gateway port of 30,000, and we're just going to let it handle that for us. If people are interested enough in Orleans, I'll do a follow-up and we'll do a more real-world demo where we host it in Kubernetes or something like that. So we have our Orleans client. I'm going to configure services. Leave that empty for now. Say build. So I always get confused between start async and run async, and I probably have them backwards because I feel like I always have them backwards. But when we want to get a client, we use something called the cluster client. So cluster client equals host services. I'm going to get a required service. I cluster client and client dot kit grain. We want a pin grain. Did I not include the reference? I probably didn't. I apologize. I usually do this, all this project management in VS Code, and I'm always unfamiliar with where these things are. Add project reference. We need our contracts. We need our pin grain, and it's going to ask us for a key, right? So in this case, a key is our string. So we're going to go ahead and say, I want the Mayor McCheese. Client dot sorry, probably get a reference to it. Grain ping. So at this point, we have our client and we have our server. We see about starting our server here. If I do this, I think I can zoom in here. Right, I'll leave this mostly for the recording. So we'll try and run our server. And I think I did this backwards. It's run that blocks. So I'm zooming in so we can see our server is running. We see a whole bunch of messages here. I don't want to drive through all of them, but it's going to tell us that we started Orleans up, all this kind of fun stuff. We're just kind of waiting at this point. So I'm going to go ahead and start our client up. And we'll run our client. And if we look over here, we'll actually see that we connect. We ran our ping. Oh, wait, we got some kind of problem here. Oh, my application closed. That's why. Feel like I should see my message in here. I'm a little slow right now. Let's change this up a little bit, make this a little easier to see. We go into our program. Make a background service. Cluster client. We'll say wait, delay. Timeout infinite. our stopping token in. We'll say var grain equals and just paste this code down here. Copy this. Let's set modifiers. Delay for time span. Milliseconds, we'll do 1,000. Oh. So to our services, we'll add services, add hosted service, worker. Oh, someone asked a question in the voice chat. Oh, I see a bunch of these things. Oh, okay. So what use do we have for Orleans, right? So that's a good question. So I kind of went over this before a little bit. In systems where we care about atomic transactions, right? So if we have like an accounting type system, it's when we deal with different account grains, like we want to be able to debit and credit transactions. We want to make sure we understand order and things like that. So from the background perspective, and there are some rules out there for what Orleans, some loose rules out there for what Orleans is good for, or really actor patterns or virtual actor patterns. So they're good for a situation in which you have client server. You want to maintain connection, and you don't want to. You need the atomic transactions. And there's a couple parts to it, and as we go through, I think we'll see that answer evolve. So in your typical simple API scenario of you have a client that's going to make an HTTP call to get something simple, like it's definitely overkill. I wouldn't use it there. Like I said before. We had a high volume reward system in the rideshare company I worked for, and I built an Orleans service that would take different transactions, and those transactions, some of them could only be rewarded once, right? So every time you took a ride, if you got a 5-star review as a rider, you would get like rewarded like 20 cents or something towards your next ride, and you could accumulate those over time. So you got paid for writing, but you also got paid for things like referrals, adding things like your email address to your account, accepting SMS messages, things like that, like different concepts. And some of those only paid once, right? So we wanted to be able to store that state in our grain and understand what rewards they already earned. So we could have done all that with SQL, with Cosmos, with Mongo. We could have done all that, and we would have had to build in a lot of that functionality. But in our case, this created a very simple programming model for us to use, where we had riders had identities. That was just a GUID, so that was our key. And as we processed through that, we were able to do simple things, right? So every time the user provided an email address, right, we would just go ahead and let the actor handle that. So we didn't have to worry and do all these checks to say, like, did this already happen? Because we had state within our actor that knew it had already happened. So in that case, it was just a no-op. Like, oh, well, okay, I've received an event. We used Event Hub, so Event Hub would receive the event to say user provided an email address. That event would have a listener and a client, and that client would call into Orleans and say, hey, this for this grain, the user did this activity, right, where it was email reward activity, and they would get awarded for it. And when we would debit against rewards, right, we could ensure that they had enough money and things like that without having to purchase a full-fledged accounting system. I actually have a small demo I'm going to go through, because once I wrote a bunch of demos over the past couple of days to help demonstrate some of these ideas. So just sort of off the cuff, like, let's make it happen. And so we can see we're pinging and we're pinging and we're pinging. And we can just see our time going up. And that's fine, right? Now, what if we want to send information, right? Because, just being able to send, blase commands is not super duper exciting. So in our contracts, right, because I want to be able to share these contracts, I'm going to go ahead and add a record, public record ping data, and we'll say name string data. And anytime you want to send data from the client to the server, you need to generate a serializer. That's it. This is all that's required to be able to send between those. So we'll go ahead and we'll change our ping information. So we'll add a ping data. Whoa. And we'll go ahead and implement this. And we'll get rid of our empty implementation with data. Data. And if we look at our server code, we don't have to really change anything, right? Because we have our silo. Our grain is doing the work. So in this case, we can just start our server up again. So we'll go ahead and kick our server off. And I'll start our sender up. Something is not happy. What did I do here? new ping data. Sorry about that. That's why you don't do live demos. So we can see here, we're just pinging the testing. It's not super exciting, but we're able to send that data across our remote barrier. Now, again, this feels like not as useful as it could be because we're not persisting or anything like that, right? This is just simple basic actor model. Up here's an actor, we're passing that in, and so I'm gonna pull over to a different repo that I've been working on over the past couple of days, and I'll transfer these things over to this repo. So here I've got our basic ping sample, which is going to look somewhat similar. Again, I've got our user Orleans client, use local cluster. I have a worker, and that worker is not really doing anything in particular. We're just pinging ourselves. For the client, our server, again, very similar layout, use localhost clustering. I have an app settings in here, but I think it's just empty. So, I mean, that's essentially the same concept, right? So just to reiterate kind of what we learned is we have our server. The things that is important for our server is that we need Microsoft Orleans server version 7. For our grains, we need Microsoft Orleans SDK, which is a participant in Microsoft Orleans server. So if you don't want this grains grains project, like you can create the grains inside of your server with no issue. Again, our contracts, Microsoft Orleans SDK version 7, and our client version 7. So in all of these, we'll see a theme, right? So I put together a pretty cheesy demo here that I called IoT client. So I have, let me zoom in a whole bunch so we can see some of this better. So if I look at our IoT sample, I have a publisher, right? And our publisher is kind of completely disconnected. So this is just Azure Messaging Event Hubs and hosting. If we look at this, our program that we're sending out, it's not doing anything super exciting. We are adding a hosted service called the publisher, and we're adding an Event Hub producer client. And our publisher is just going to send tons and tons and tons of data to, well, relative tons. So I can increase our load quite a bit. So I can add some more sensors. 11, 21, CEO 11, CEO 21. So if I go ahead and start this guy up, all he's going to do is send information to our Event Hub. And if I pull up our server, I'm going to go ahead and start a new server. And we can see I'm receiving all of this data. I mean, this is just flying in pretty well. And it's just updating its data. And I have a really, really, really badly written WPF app where I'm just asking for information about 2 of those sensors. I'm going to go ahead and update. I have broken something here. This is why you don't do live demos. I'll have to look and see why that is so that folks can run this and see what's going on here. I don't want to take a bunch of time to debug through why my WPF app isn't working. I've just done something silly somewhere. But the idea is that as our sensor is running, oh, okay. I think I see what the problem is. I had too many silos running, and they're all using the local dev cluster. So let's try and start this over again. So I'm going to go ahead and start my publisher. We'll go ahead and start our server. And I think that was probably the problem. If it's not, we'll move on. Oops. That was starting a different client. Yeah, so I can just update these, and I can see our sensor data is updating, and I can start another client. And I can see just information that we're looking for. We're reading from the client. I've got our WPF app. We'll update it. It is possible for actors to deadlock, but it's pretty rare. So all these things happen on a single thread for each actor. So each actor, you don't have to worry about, oh, I have 6 different clients, right? So from the IoT situation, I might have like a TV monitor somewhere that's monitoring a whole bunch of sensors that are showing me temperature data, like on some cycle, and maybe we have some adorner pattern here or something where if it's above temperature, like it turns red. But then maybe we have other clients that are running, right, that are more automated, that are taking that data and putting it into a data warehouse, right? So we might have 20 or 30 different clients in an IoT scenario reading from the same sensors, right? So Thinker asked a question about that, right? And so in our simplified programming model with Orleans, we don't actually have to care. We don't have to worry about like, well, am I going to deadlock an actor? Do I have to worry about other clients that are running? And I don't have any special complexity here within our scenario. So if we just run through this, the most complicated portion here is really just my publisher, right? My publisher has about 20 lines of code, and we're just sending randomly bad data. And our server has a temperature processor, and this is just an event hub processor that pulls this data in, and it's just getting a grain, and it's just calling this monitor method. So if we look at our contract, from learning an Orleans system, right, you always want to just look at your grains, right? What do my grains do? In this case, I have a monitor where I'm passing temperature reading data in, and it's just a record, sensor name, temperature, humidity, and the reading date time. If you do find yourself in Orleans 3.0 land, you have to be careful because Orleans 3 and records are questionable. They don't work very well in Orleans 3. I believe the latest version of Orleans 3 supports records, but at the time where I used it, they had not supported it yet. But they're fully supported in .NET 7. And our get sensor data, if we our grain just returns our temperature reading that we're storing, right? So if we go and look at this grain, I've added a real simple persistent state here. So like I said before, grains don't have persistence unless you decide you want them to have persistence. So let's talk through that. So if we look at our server and we look at our program, I've added an Azure table storage grain storage called temperature store, and I'm passing in a connection string to my Azure table storage. Now, you are not required to store grains. You aren't required to store them in Azure table storage. You can store them in SQL. You can store them in Redis. There is a number of NuGet packages that are available. And if those don't work, you are more than welcome to write your own. There is a programming model to write against that's available inside of Orleans documentation. They discuss how to write your own grain storage. I've written a grain storage before that worked with Cosmos database that stored journaled grains. We'll get to journaled grains in a minute because that adds some interesting dimensions to a grain. So we're just storing our data out there. Let me pull my browser up and we'll go to, yes, I use Edge. Oops. So if I look at this Night of Orleans, and if I go to our Get Storage browser, I can see I have all of our grains stored out here. 1, 11, 2, 21, right? All the ones that we added. From the perspective of our sender, right? Those grains don't exist until we tell them to, right? And our IoT temperature publisher doesn't know anything about Orleans grains, right? The only thing he knows about is his sensors. So he's reading from various sensor data. He's publishing them out to Event Hub. Our Event Hub only nominally knows about grains. So our Event Hub temperature processor only has this realistically one line where we process the event data. We get our grain by grain ID. So if our grain we process event data, all we're really doing is deserializing the data. I'm logging some information just for clarity, and we'll go ahead and we'll just log that name with the sensor name. So when those don't exist, our silo will just create them. We don't need to worry about doing anything particularly difficult to handle that. So the thing I want to highlight here is that in a relatively small amount of code, right? Really just a lot of setting model data, setting up our cluster settings, setting up our grain storage. We have a pretty primitive IoT system that could read sensors from all around the world, different clients, right? Published from different types of sources, and we didn't have to write all that underlying code. This is even a function of trying to think of how I want to say this. Adding new types of sensors, temperature sensors. Like we don't care about that. Adding more data, right? If we want to add new functionality, we would just add it to our grain. It's relatively simple to do, and we don't have to worry about the different models that are out there. We don't have to worry too much about building in everything with Orleans. So if we were to do this through any web API scenario, right, you've got to build out the controller, you have to build out a bunch of that data, you have to build out the mechanism for storage, you're going to add that to SQL, you're going to add that to something else. And and all those concepts are great, but Orleans is going to handle that for us, right? So that's in my opinion pretty valuable for a software developer to not worry about some of these things. To not have to build out a whole system under the covers. And like I said, I wanted to talk about ledgers a little bit. So this is where things get a little bit more complicated. So I want to take a look at our program. So again, let's go through our NuGet packages first. I have Microsoft Orleans Server, and I've added another NuGet package here called Microsoft Orleans Event Sourcing. Event sourcing exposes us to something called a journaled grain. So that allows us to store interim states of data. So in terms of an account scenario, let's say that we were working on some sorry, I'm laughing at Cassandra. So yeah, I lost. Here's our event sourcing. We have our contract, which is just records right now, and an interface. I should have put this in its own. Our records, I have an abstract transaction. This is transaction ID and an amount, and just for object encapsulation and sort of identification here, polymorphism, all that fun stuff. I have a debit transaction and a credit transaction, and they're both just a transaction ID and an amount. So something that we'll run into when we think about like a ledger system is if I get paid and I have a transaction ID of like paycheck 1 and it gets sent to my account twice, like one of those should not be received, right? So otherwise I get double paid, right? So if we look at our client, our client is relatively simple, right? I just use Orleans client, I create our cluster client, I create our ledger grain, I have an account called Mayor McCheese. I'm adding a paycheck 1, I'm adding a paycheck 2, both for $5,000. I'm going to assume that's dollars US. And then I have a debit transaction where we're buying a book for $10 and I can check my balance. So if I go to our server and I look at our program, I have a journaled grain, right? So journaled grains require a state. In this case, our ledger state just has our account balance. And we have these methods called apply. So we're going to apply a debit transaction and a credit transaction. You can see there's no references. This is a danger zone for Orleans, right? Because I'm going to come in and clean up code and say remove unused method. Visual Studio ReSharper doesn't know that this method is in fact used. So this is a scenario where you have code writing code for you under the covers, and things that don't look like they're being referenced may well be actually being referenced. So we'll get to more of that in a second. And then I have the event type. So our journal grain has a T grain state and a T event base, right? So our state is a ledger and our event is a transaction. And I have our I ledger grain. And remember, our ledger grain, right, there's no difference here, right? It's just in our case, it's a grain with string key. And I'm calling in that we have a debit and credit transaction. And so our debit is going to take a debit transaction, our credit is going to take a credit transaction, and we can return a decimal that's a check balance, just to make our lives a little bit easier. So this is, for me, I don't want to store all these records in single files because I'm not a monster. And so a lot of these one-liners I'll stick into a records bucket, for these simple types of records. In the case where these are all related, I might call it transaction records or something like that. Again, that's just me. So Microsoft Orleans SDK, I have our hosting. The reason the hosting is important this is a mistake on my part. The contracts doesn't need hosting. Just for any, I'm going to leave it alone for now, but that was mistakenly added on my part. But if we look at our client, our program has a host. I accidentally added the contracts and not client, so that's why you don't see it in the ledger client. So when we say use Orleans, right? Using Orleans is gonna add in all those concepts like our grain cluster, our grain factory, things like that we don't necessarily have to care about. So we just want to get a reference to our grain and send this information in. So I'm going to go ahead and make sure my server's still not running. Okay, so we'll go ahead and start the server up. There shouldn't be anything too exciting here. We'll zoom in a little bit. And I'm going to go ahead and start our client up. And we'll start a new instance. Something was not happy here. That's why live demos are miserable. I don't think I have another silo running. We'll step into our new instance so we can walk through this. So we're going to go ahead and we're going to add our credits. And I can see a number of things happening, right? So we're in a debug state, and things are taking longer than Orleans is expecting. So Orleans is telling me, wow, you got problems. Like your cluster is not working as well as you should hope. And that's not a bad thing. You can send telemetry to, you can send telemetry to things like application insights, and there are NuGet packages for that. So where is our output here? Right, so I can see our output, right? I attempted to output our initial check balance, which was 0 because it's a brand new grain, because our silo wasn't running before. And I've added a credit of 5,000. I've added another credit of 5,000, right? And we get we charge ourselves for our book, and I run the account balance again, and I see that we have that completed, right? So if I run this a second time, I want to bring this out here for clarity. Our balance is still the same, 990, even though we added our transactions, right? We added paycheck 1, and we can see here that we found a duplicate transaction, right? So paycheck 1 found, paycheck 2 found, duplicate transaction book found. Right, so we don't actually change anything, even though our ledger system called for it. So if we look at our grain, our ledger is going to do all the work for us here, our grain. So again, we have our state, which is our ledger state. Excuse me. And that's just built into our grain under the covers because we have a journaled grain. So that'll, Orleans will handle out, Orleans will handle all the grain functionality in regards to our state. So we have our debit, and I have a method here. This is a method in the journal grain that's called confirm events, right? So what we're saying with confirm events is make sure it's written to our state, right? So they will eventually write, and they write in order that they're received. But if you don't have a confirm events, sometimes you can get some awkward results in certain scenarios, to where you might report data that isn't fully committed yet, and then when that state is eventually consistent, the result that you initially got could be wrong, right? So in our debit scenario, I want to make sure that we're consistent. So I'm demanding that our grain become consistent. So I'm saying confirm all your events, and I want to check and see if our transaction exists. So our journaled event has something called a received confirmed event, and I want all of our data. So I'm going to start with the 0th version. By default, journaled grains versions are stored in integers, 1, 2, 3, 4, X, and version is the latest version when all events are confirmed. So I go ahead and get all events, which is a read-only list of our transactions, and I'm just going to run some simple link to say, does our transaction ID match inside of our events? Now, let's be clear. Like this is not the most robust transaction system in the world, right? But for the purposes of our demo, right, we can ensure that anything that has a duplicate transaction ID we don't run again, which is pretty powerful tool for a dev to be able to use. So we don't have to build in any of this, any of the event sourcing systems, right? We don't have to store this anywhere. Well, that's not completely true. I do have to give it a log consistency provider. Right now, I'm adding the log storage based log consistency provider as default. So when you throw these things in as default, what you're telling it when you say as default is that any grains that I don't say otherwise are going to use this log consistency provider. So I could add a log consistency provider and give it a name, and then reference that named provider on the grain. And I want to store the memory grain storage in memory by default. I don't want to have to tell each grain to store in memory. So instead of decorating each grain with a log storage provider and a grain storage provider, I can just go ahead and say do it as default. Like I said, I don't have to build out those systems. And again, you can write, there are other systems that you can provide. You can download you can download log consistency providers from NuGet. There's like Azure Storage Table ones, Redis, SQL, things like that. In this case, I just want to store them in memory. So I'm just using the log storage based provider. Not all providers are equal. So when you're using a log consistency provider, you really need to check your P's and Q's and make sure that that you're doing what you expect. Let me see here if we have any other questions before we move on. just going through and reading some of the questions here. Oh, yeah, okay, so this is very similar to durable Azure functions. It's, Azure functions have durable entities, um, and you're kind of in Azure at that point, right? So durable entities have a somewhat more complicated programming model. In some respects, it's simpler, but yeah, durable entities, I think, even call out that they're something like a competitor to um, Orleans. One of the advantages of durable functions in terms of entities is durable entities are guaranteed not to deadlock. Um, it is possible to deadlock Orleans. So there are some other differences there. There is, from a Venn diagram perspective, some crossover. If we were to vent out the sort of competitors here of Azure Functions, I should say durable entities, or Orleans, Akka.net, Dapper, things like that. If we were to Venn diagram them out, like they do cover a decent bit of area that's well shaded. Dapper and Orleans are going to be somewhat close to a full union on the Venn diagram. Azure Function is going to be missing some functionality and have some others. So there are some differences. I can't really go through all of them, but as Werewolf said, you don't have to do it on Azure. So there is some parity there, but I think that overall, in a very high functioning system, in a very high transaction system, durable entities have some cost issues, things like that. So functions can get quite expensive if you don't do things right. And I'm a monster. I don't like Azure Functions. I know I'm probably the only person in the world that thinks Azure Functions are terrible. But in my mind, they're horrible. And it's not actually that the technology is bad, and it's not that the implementations are bad. It's that people want to do things like add dependency injection into their Azure Functions, and it's a real serious bolt-on, and things like logging don't work the way you expect in Azure Functions, and suddenly like all your telemetry isn't working the way you expect. How Azure creates functions isn't well documented. There's just a lot of little gotchas in Azure Functions that are not well known. And some of them I have only found out recently, that in some cases I wasn't aware of, and made some naive usage of, and it kind of bit me in the butt a little bit until I found out and had to make some changes. To me, the main difference between Orleans using Redis and the manually created are Orleans caches grains in memory and fetches that when receiving messages, while a classic stack needs to create a SQL database every single time. Orleans requires you to write actor-oriented code, while the classic stack needs to do some weird stuff with transaction boundaries and sagas. That's correct. Orleans manages persistence and error handling for you, while the classic stack requires extra care when a transaction fails, when a message gets resent, etc. So why even bother using the stack I mentioned? So again, Orleans is not going to be for every single thing out there. So if you have a well distributed system, where in our transaction example that we just walked through, right, you could end up with some hot scenarios, right? So let's say we have an account that receives a lot of microtransactions, so 10, 11 cents at a time. from all around the world, the Orleans grain can only exist in one silo at a time. So that means you might need to deal with some placement strategies and some other grain scenarios. So there's something I didn't want to talk about called a stateless grain. So stateless grains, you can have more than one stateless grain active at a time for a given identity. I've experimented with this a little bit of using stateless grains to channel information in. I've not been super successful, but I haven't tried that hard either. So again, the part of the weakness of Orleans and virtual actors / actor frameworks in general is that everything is single threaded for a grain, right? So transactions come in, and if I'm getting millions of transactions at a time in that microtransaction scenario, I'm going to have serious bottleneck. So that's probably a bad fit in that scenario. In the case of, we were talking about the rideshare reward system I wrote. The rideshare reward system had some natural boundaries around how real world actors could act, right? So the real world actor, the rider taking a ride, like there's only so many rides they can take at a time. It turns out to be one. And there's only, and while they could change their email address multiple times, they can only change their email address at best a few times a second. And because it was required to go through the app. So at best, you're gonna type your email in the app and hit update. Type your email in the app and hit update. So no real serious bottleneck there. So it was a good fit. We theoretically had hundreds of thousands of riders in the markets that we were in, but they weren't all going to be active at a time. And so we expected our goal was to have 18,000 active rides per second. Our goal was that because that's what Uber's goal was at the time, was 18,000 per second. So we wanted to support a similar set. So again, it was a good fit there. There is some, you have to go through an internal checklist and think about, am I going to create a worse system for myself? There is overhead for Orleans in terms of hosting, right? So right now we're hosting everything just on my local dev box in a in-memory cluster. But when we start thinking about different hosting types, Kubernetes hosting, are we hosting this in a virtual machine out in Azure somewhere? Like how are we going to host this data, right? There's additional concerns that come in at that point. So there's a give and take for everything. And like Microsoft says, an Orleans cluster, a single silo can hold a virtual grain for every person in the world without blinking. But that assumes that you're only going to have a relatively small percentage of those grains active at any one time. So if we think about our activation cycle, right, we activate in memory, we do some work, we deactivate that grain. Orleans will deactivate that grain for us under normal circumstances. And when that grain is deactivated, it'll persist that data to whatever our storage mechanism is, whether that's SQL, whether that's Azure Table Storage. And then when we activate that again, we're going to pull that out of our grain storage. In some cases, we might not care about the grain storage persisting the data. So in the inventory system I talked about initially, we skipped the idea of persisting things at all. So anytime someone wanted new inventory, we held that in memory. In our storage, we ended up using Redis cache for our storage. Because we didn't care how volatile it was, right? Because our sources of data were the sources of truth and not the Orleans grain. The point of the grain was to absorb the load of the user having to go out to these various data systems to get data on a relatively frequent basis. So instead of having a user from an API be sort of the victim there, the actor had to absorb the compute heaviness, and so that when users came in to ask about inventory, whether that user was another system or a website or manufacturing systems that needed to understand if we had inventory available and if we had raw material to work from to build out new pieces of inventory. They were able to just query the state, right, and say, hey, what's your current state? So it was a relatively good fit there. And authentication actors, I'm going to save that for a follow-up. I don't want to go too much into that right now because we're covering a lot. I'd rather do a session that was dedicated towards authentication. How do you handle communication between grains? So user grain is getting deleted due to GDPR. We need to anonymize anything that relates to that user grain. So grains can call other grains, like that's an actor paradigm. Actors can create and deal with other actors. So the manualness of that point, at that point, deleting a user grain, right? The user would start to pull any grains that you knew about. You would know about them because you've written the code for this, right? So the user grain calls like some other grain that it's aware of and deletes those things, and then those grains, when they're being deleted, would need to call out to other grains that they're aware of and delete their data. Grains have an ingrained ability to create new actors of different types. There is a pretty good samples page out in the .NET samples. Has a whole section dedicated to Orleans. And there's something called the adventure game, and the adventure game like has players, and players exist in rooms, and there's mobs, they exist in rooms, and players interact with rooms and mobs, right? So it might be worth looking into that. I kind of purposely skipped over grains, dealing with graves right now, in case we want to do a follow-up. Meanwhile, are there any questions about the journaled grain or the ledger in general? If not, I want to talk about timers and reminders. I'm personally running short on time, so I'm going to just kind of go through the code from a perspective of, what are the packages that we needed, right? So in this case, for our reminder system, your minimum set for Orleans is a server, right? So you have to at least have that. You have to have grains, or your silo just sits there. But you could just create a silo and it would do nothing. But your minimum is a server. So in this case, for this reminders demo that I worked on, I have just a simple worker, and all the worker does is tell my grain to do a new honeydew grain, and it's going to act and take out the trash, right? So let's kind of run through what we're doing. So we have a localhost clustering. I'm using an in-memory reminder service. You don't get reminder services by default. You need to include a reminder. So I have Microsoft Orleans reminders. This is the in-memory reminder-based service. There are other reminder storage mechanisms. That's a theme you'll see a lot with Orleans, is that there's a base, simple, this is our in-memory version, and then built on top of that is things like Azure Table Storage, SQL, Redis, etc. And then built on top of that is your ability to create your own. And they have a lot of programming models. I do want to mention that there is a very fantastic Orleans Discord. The maintainers of Discord, the maintainers of Orleans on Discord are very active there on Discord themselves. So like Ray Bond answers questions there all the time, and things like that. So it's just let me think here. yeah, it's just the Orleans Discord. I'll throw a link to the chat into it in the chat before before we're done. So we have our reminder. So there's two types of reminders within an Orleans grain. There's a timer, and timers are meant for short amounts of time. Like I want to I want to set this timer up every let's say second to do some work, and maybe that work is it's not really important whatever the work would be, but timers are essentially just the system timer that you're somewhat familiar with. The important thing about that is that timers don't keep your grain alive. So if you have a system timer running on your grain, it's gonna do that work. It's gonna do that work. It's gonna do that work. And when Orleans decides that it's time for your grain to be persisted and deactivated, it's not gonna care that there's a timer running, right? It's not gonna say, oh, I've got a timer coming. I'm gonna keep that turned off. I'm gonna keep this grain active. It's gonna go ahead and persist it, and it's not going to handle that, and it won't do anything with the timer again until that grain gets reactivated, in which case that timer will continue. So it's kind of for non-essential work that doesn't need to happen. It can happen as frequently as you want, but it's not critical. Then you have the reminder service itself. Those are for longer running ideas, right? So they get persisted into the reminder system. And so the reminder system is capable of reactivating a grain and calling out to do that work. So there's a couple gotchas there. If I recall correctly, if your grain is deactivating in the deactivation cycle, it's not eligible to participate in the reminder system. So if you had a reminder system that was happening every, let's say, 2 minutes, and somewhere in that 2-minute range, your grain is in a deactivation state when the reminder kicks off, that won't keep your grain alive, and it's possible to miss. And then the next time that reminder came around, your grain would wake up. And if I recall correctly, the reminder system tells you that you missed at least one of these things. So they're for tasks that you want to be able to be fault tolerant for, right? So if you're doing something that is 100% this needs to happen, then it should be an action on the grain, not a reminder. But if it's something that you need to happen relatively infrequently, it's not critical, you can consider a reminder to handle that. The reminder system is pretty simple. Like again, I said I have the use in-memory reminder service. I have the my grain, the grain with string key, and I just did a simple method called act because I couldn't think of anything better. This is something I run into a lot when I think about reminders and timers. Is like, what are good examples for them? And I usually don't end up having good ones to talk about, so I just kind of make something up. One thing about the reminder perspective is, and the documentation calls this out, that when you think about reminders, think about minutes, hours, days, not seconds, right? If you're in the seconds land, like, you don't want to use a reminder, you want to use a timer. And so in order to add a reminder, it is an extension on our grain. So like all grains, we have to inherit from our grain, and we add the iRemindable interface. iRemindable interface gives us this receive reminder. And so we have our reminder name and our tick status. This is where we talk about, like, what, the status of a tick when the tick is delivered. In the case of failures, it may happen that a tick is not delivered on time. The app can notice such missed ticks as followed. So there is some documentation around missed reminders and that sort of thing. So when we create a reminder, if you think about like a set timeout in JavaScript, like you have that timeout handle. So in this case, I'm storing the grain reminder here, and we could add an unreminder, right? So this is register or update reminder. In the case of our simple trivial example, we have our act reference, our act grain action, where I give it a textual task and the seconds, and I register the reminder and pass in the task, which gets me a reminder back. And then I'm just going to store that reminder in the case I wanted to unregister it. Unregistering a reminder would be unregistered reminder, and you pass in the iGrain reminder that you had. So if you don't have a reference to that handle, like it's not. I'm not sure of how you would unregister at that point, so always remember to keep your reminder handles around so that you can delete them. Juju asked one thing about grains and Orleans and any actor model is, and this becomes very important. You don't mess with your data store. So there's no such thing as row surgery. So row surgery being like, oh, my SQL, there's something wrong with my SQL. So I'm going to go in and fix data, right? I'm going to go in and modify this manually. And that is a very bad thing to do with actors, right? If you need to do that, then you have a programming problem somewhere. And you don't want to do that type of row surgery. You could physically go in and delete a reminder because it's a different type of record, but going in and munging your data in a record in an actor system is usually inadvisable. So when I think about different ways to interact with with the system, so we're building an Orleans system at work right now to handle inventory again. Because I went back to work for the same company, and our inventory system is still kind of in a very tragic state. It's no longer on Orleans. It got moved to a traditional API, and it's very, 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 very slow again, sometimes taking 15 to 20 seconds to return data, depending on the type of inventory and its consistency in the cache. And I'm thinking about, one of the things I'm thinking about as I architect the solution out is how are we going to handle that, right? So we have ingestion to Orleans that's coming from data sources being updated and raising events into either our event hub or sending commands to our Azure Service Bus. So those are our primary ingestion points. But then I have an admin API where we can send transactions in to essentially fix if something is like somehow tragically wrong, right, in a short term, to give us time to update the original system of record and have that flow back in through a surfaced event in our event sourcing backend. So I'm going to go ahead and run this, and we'll start a new instance. And again, this is just a server. There's no client for this. Right now, it's just going to sit here, and every once in a while, it's going to honeydew, take out the trash. And because I feel like with 2 kids, 3 dogs, and a wife, I am taking out the trash at least every 10 or 20 minutes. It's not really the case. I'm kidding. I feel like it. But we'll see this work on a relative heartbeat. I think it's every minute it'll tell me to take out the trash again. The reminder service is not always super accurate in terms of, like I said before, from the activation deactivation cycle. It's not going to be wrong by like hours, right? But if you, it could be off by a few milliseconds or a second. So if you're trying to use reminders and timers for something that's critical. Again, we don't want to do that. We want to manage that in the through the actor grain themselves, through actions. So something that you'll see happen. So I have a 60-second timer on this guy. I'm going to go ahead and make this like 30 seconds or two. 20 seconds sounds like a win. And we'll go ahead and run this again. I'm actually going to get an exception in here. Cannot register reminder, take out the trash as requested, is less than minimum allowed reminder period of 1 minute. Depending on the provider, I think that's configurable to lower that number. But again, it's not advised to have reminders running on an extremely frequent basis, because they'll keep resurrecting your virtual actors, right? So in the scenario where we have a grain for every person in the world, if we had a reminder for every person to brush your teeth in the morning, like we would be taking our silo down all the time, because we'd have droves of grains waking up all at the same time and running whatever reminder process that gets picked up. So our reminder has a description of the task, and we'll look at that task and say, okay, well this reminder just perked up and the message is this, I need to go do this, right? So if the reminder was to brush our teeth, and we're waking up 10 million actors at once, like our silo is going to take a big hit to wake up 10 million actors, to hydrate 10 million actors, their state, to brush their teeth all at the same time, and then to manage things like that, right? So that could be a serious flaw, right? We don't really want our system, our reminder system, to help take our silo down. So this is all I really have today. I hope this was informative and gave you some ideas on how you might use Orleans. And if people are interested, like I'll continue the series and work on some real world scenarios in a couple weeks. So just let me know what you want to do in that regard. I am putting this out on. We're going to upload it to the C# Discord and to our YouTube channel. I'm recording it on OBS right now. So I'll give folks a couple minutes to ask some questions. What did the grain of salt say to the grain of sugar? You're so sweet, I'm feeling a little salty. Oh. So if anyone wants to reach out to me and say, I'm interested in, Swearwolf has a question. Go for it. Okay, so that's a good question. How do multi-silo with cross-grain communications work? So silos know where grains are placed, right? So there's in the case of a multi-silo solution, except in certain scenarios, certain specific scenarios, where you programmatically instruct that a grain can exist in more than one silo. Those are called stateless grains, and you can have multiples of them. Otherwise, a single grain always exists, and Orleans is aware through something called a placement strategy where that grain is located. Orleans is fundamentally aware of any grain that exists within its system. So when you have one grain talking to another grain, Orleans takes care of that communication. I don't know all the underpinnings as far as like if I have a silo in Singapore and I have a silo in Texas, and those grains are in those silos, like I'm going to add some latency. So that could be a problem. Now, That's where placement strategy comes in. There's 4 or 5 default placement strategies. Can you move grains between silos? Yes. I'm not sure how to do that. But I believe you can instruct grains to move between silos. But some of the placement strategies that they have is like round robin, least busy, most busy, and I think there's a geographic one that's out of the box, right? So if you're in Texas and you say, I'm going to create a grain, and your nearest silo is like Pennsylvania versus like Singapore, it's going to use Pennsylvania. Now, that being said, Orleans is all about doing it, right? It's about getting everything done, and if there's not something out of the box, then you have a relatively simple programming model to build that. So you could build a new placement strategy. Now I say relatively simple, right? Because you're going to build in whatever that placement is, right? So you'll be filling in like 1 or 2 interface methods, or handling 1 or 2 abstract class implementations, right? And that's kind of a Orleans theme that you'll see a lot when you end up processing something, when you end up having to build something. Like, you don't come across these giant interfaces that are like, wow, I want to build this placement strategy, and in order to build a placement strategy, I need to fill in 300 other interface methods that I'm never going to use, right? So there's a lot you'll see there where building functionality in is relatively simple. You don't have to go through the rigmarole of trying to make things a little bit crazy. I haven't covered unit testing or anything with this. It is possible to unit test within Orleans. So you can create a cluster in test mode. Something we did at the ride share company I worked for was pretty interesting. I did not do this. Another gentleman that worked on it did this, but we used SpecFlow. And part of the reason we used SpecFlow is that it allowed us to describe everything that we were going to do. So we had like a driver named, Rick would pick up a rider named Sally at this location, and whatever that geographic location was. And we could describe everything about them, and all that every one of those statements would call a grain to set some of the state. And then we would execute our flow against that state, right? So that became super flexible very quickly to be able to create testable scenarios. So testing within Orleans is pretty interesting, from how you can run a test cluster locally and set the state that you need without having to do like crazy mocks or anything like that, because you're just running a silo locally within your test. You're setting everything up exactly the way that you expect to be able to support your test success or failure, and then run through that process. So from a unit testing perspective, Orleans is very flexible as well. And let me see, can't think of anything else right now. So I guess if no one has any other questions, I'm gonna go ahead and end the recording. I got Juju calling me out. Be right back. And a host Orleans on queue. Orleans and message delivery guarantees. How do they work? How durable is it? Are you fucked if your command doesn't get sent, or the silo while doing the thing? Let me get back to you on that. It's a little bit complicated as far as that goes. Delivery is kind of guaranteed. So it's a client server relationship, right? So you're going to send that off. If your message doesn't get processed, your grain is going to let you know, right? Like, this thing didn't happen. Deadlocks can happen, that sort of thing, right? So it's not like your message necessarily gets queued up and sits there. this is all single threaded, right? So you can get some bottleneck problems that happen if you have too much work on a single actor. Um, and does it make sense to have strong relationships among different grains so their life cycle are attached to each other? Not sure if they can get messy and coupled specifically when they might be in different silos. So you don't really have a strong relationship between grains. So you have one grain that can call your grain can call other grains, right? But that doesn't necessarily mean that like when one grain hydrates that it's gonna hydrate the other grain. I should use activate and deactivate because that's the official term. So when your grain activates, it doesn't mean necessarily that other grains are going to activate because you're activated. So when you call actions on that grain, if they need to call out to another actor to work, that's when that grain would be activated. So the state for the grain is its own. It doesn't belong to. So you don't mix state between grains. So and even types of grains, right? So in terms of if we had like a demographic grain, and we had people, right? I exist. I have a head. I have feet. I have arms, legs. You know, I have a torso. All that stuff, right? But I don't exist past that, right? So my arm and my wife's arm they're completely separate state. Sometimes they mingle together. You know, we're walking, we hold hands. You gross. I'm just teasing. So sometimes those states mingle depending on the action that's happening, right? So we're walking, holding hands. I have balance issues, so I don't hold hands. But anyway, apparently I'm rambling issues too. But our states are uniquely our own, right? So there's not necessarily a strong relationship. And so their life cycles are not attached to each other either. Did you expect Emily's analogy with holding hands? And that was amazing. I did not. So I just kind of winged it. Yeah, I mean, you know, it's at some point, every grain has its own state. And if you mingle state between grains, you're asking for trouble, right? You definitely want your state to be 100% owned by a grain. You didn't expect it to get lewd. It's not quite evening for me yet. It's almost 5. And we have Patrick typing something. Hopefully I can find and activate a grain one day and share a silo with it. I got nothing. All right. I expected looking at the stars because it's an evening. Orleans, who does point one anyway? Actually, I do some stargazing and stellar photography. I'm not very good at it, but it's something I try to do. It's hard to do stellar photography because light pollution exists. Yeah, I agree, Patrick. I think we're pretty well covered. All right. Again, if anyone has any questions, feel free to just reach out to me direct. I don't mind at all. And I'm going to take all the code that I demoed today and mix it in with that repo and go from there. And